So a B plus tree is an interesting variant of a B tree, which brings up the notion of maintaining all data in the leaf nodes. And since we've already studied a B tree, it will be easier for you to understand B plus tree, which is just some variation in B tree. And the main goal of a B plus tree is to have all the data stored within the leaf nodes of the tree. So let's just create an example. Let's take an example and create a B plus tree of order 4. And these are the values that I'm going to insert. So first I'm inserting 1. And because it's an order 4 tree, I can store maximum 3 keys in one node. And that means that node can have maximum 4 children. So this is one node where I'm inserting 1. And now after that, the next thing I want to insert is 3 and 5. So I'm inserting 3 and 5 directly, and 3 and 5 are inserted, as you can see. Next, I want to insert 7. So in order to insert 7, there is a problem, which is that there is no space in the topmost node, and that's why we have to insert 7. We have to increase one level, and to do that, just like a B tree, we are going to pick the node that we want to use to take it up. And we want to take, there are 1, 3, 5, and 7 together. So we can either pick 3 or we can pick 5 to go to the top level. And if you pick 3, that means you are trying to pick the left node. And if you pick 5, then it means you're trying to pick the right node. Whatever decision you make at this point, that should be followed even afterwards. So if you are taking 5 and then you are picking it up to the root node. So if you take 5 up, a level up, then in the bottom, you're going to maintain a copy of 5 because it's a B plus tree. This is the variation that we talked about earlier. So I'm going to keep 5 in the bottom also in the leaf nodes. It's a copy. Every node that is on the levels above the leaf nodes, they all should have one copy in the leaf node. So that's why I've kept 5. Next, let's insert 9. That's fairly simple. You can just insert it next to 7. Now next we are going to insert 2. To insert 2, I can move 3 and insert 2 because it has to be sorted. And there is space. And 2 is less than 5, so it goes on the left-hand side and it can be easily inserted. The next thing I want to insert is 4. So to insert 4, I need space on the left-hand side of 5, but it's already filled, which means one of the keys will have to go to the top level. And because I have 4 keys, 1, 2, 3, and 4, I have to pick one. The last time I picked the one on the right side. So this time also I need to pick the one on the right side, which is 3. So 3 is taken to the top level, and the nodes which are there below are just readjusted. The next thing we have is 6. So for 6, we are going to place it on the right-hand side of 5. But once again, there is no space over there. So it's going to be 5, 6, 7, and 9. And in order to place it there, I need to take one of the nodes to the top. And at this point, if I take one of the nodes to the top, then it would be 6 going, because it is 5, 6, 7, 9, it would be 7 going to the top. So 7 goes to the top, but once again, the copy of 7 is maintained in the leaf nodes on the right-hand side of 7. So right-hand side of 7 still has 7 along with 9, and left side of 7 has 5 and 6. And that's how we have inserted into this. Next, we want to insert 8. To insert 8, we need to go to the left-hand side of 7, and there is space. So that's fairly simple. We can just put 8 over there. And next we want to insert 10. So to insert 10, we have to go to the right-hand side of 7, but there is no space in that node. So I need to take some key to the top level, which would be 9. And once I take 9 to the top level, there is no space for 9 over there either. So next I need to select which key from there to take to the top level, and that would be 7. So I will take 7 to the top level, and on the left side of 7, there will be 3 and 5. On the right side of 7, there will be 9. And then for 9 on the left side, there will be 7 and 8. And on the right side, there will be 9 and 10 because we need to maintain the copy of 9. And the rest of the tree is just readjusted in the same manner. And now you can see that my leaf nodes contain all the keys. There were totally 10 keys available, and all 10 keys are present in the leaf nodes. So what you have here is a tree that is fully a B+ tree with all the nodes present in the leaf nodes.